Yes, thanks. Well, welcome everyone. Welcome to Triple. My name is Jeroen. Nice to meet you. I've been here for over 6.5 years working for Triple. And Triple is like an agency, for the ones who don't know, like an agency where you can, as a business, come here and we can do your apps for you, your design, concept, innovation, hosting, websites. We have expertise in, I think, almost every field. But we can also do something specific for you. And I'm lucky enough to have been part of Triple for over 6 years already, and I've worked on the Vodafone app, the Ziggo Sport Totaal app, Film 1 app, the Sport 1 app, the ESPN, Fox, Videoland, RTL, Buienradar. Super bass. And currently I'm working on Citizen M, so as you already can hear, we have a lot of projects going on. In here we usually work in teams, where as a developer you're either working on multiple projects or single projects. In my case I'm working together with another iOS developer and 2 Android developers on Citizen M. And Citizen M is like a hotel app where you can use your phone to check in, scan your key card to unlock your room. Unfortunately, Apple doesn't allow us yet to use the Apple Wallet, but on Android you can use your phone to open the room. You can control your room controls, like the lights in your room, the ventilation, the temperature. So that's really awesome to do. And you can also order everything. So like a contactless experience is the goal. So that's really great to work on, because I used to work a lot of media apps, but I was always on the phone. But now I'm working on an app that interacts with the outside world, what is really interesting. So it's great to have a lot of different approaches and apps where you can try out lots of different things. But today I'm gonna talk to you about Async Await. But first, I want to have a little recap, because we're finally back together. Because as Bart mentioned, our last live meetup was in February 2020. Feels even weird to say it. But it was our last real live meetup, where we had even 3 talks and came together with a lot of people. As you can see, everything was like close to each other. Corona didn't exist, and then unfortunately the next month after it, everybody started working from home. Even us, like we even did like first a tryout. Let's see if all the developers staying at home, if our servers can handle that with our VPN. And then suddenly we heard, no, you're gonna stay there. Everyone stays at home. Good luck. And well, luckily we could get all of our equipment from here if you didn't have that. So that was a fun experience. Luckily, because we're already working with our laptops as developers and already working remotely at our customers sometimes, we got a whole system in place, so it was rather easy to slide in. And then of course, the next month, we had our first online meetup from CocoaHeads. From asynchronous programming with operations in Swift from Antoine. Unfortunately, he's not here tonight, but that was like also a great addition, that we as a developers quickly adapt to the current situation, which is go online, have a meetup together, so we still feel connected and share our information. So that was really awesome that we did that. And the following up, well, as you can see in our the CocoaHeads meetups, there were like tons and tons of online videos. So it's really great that we kept this going on. And of course, a few months later, we got the dub from 20. And that was also like an interesting part, because usually you sign up and then you get luckily that you get elected to pay 5,000 euros, and then you go to America. But they also changed the whole concept. It was the first time they did it online. I really liked it, even though the timing difference in here, of course, was horrible. But luckily, in here we received days off, so we can have a full time on dub, and we just started on Tuesday, because starting on Monday evening, so it's a little bit awkward. But on Tuesday evening, the talk started coming out. So some people even went online at like 3 AM in the morning. I didn't do that. I just go on Wednesday morning. I'm just gonna watch everything from Tuesday and then continue on trying stuff out. We had some talks together in teams to discuss things, try out things. But in there we heard like even more SwiftUI, of course, from the last dub. Even more advances in collection views with your data sources and the compositional layouts. New logging APIs and some other stuff. But this was the most interesting part for us. And if we continue to go further, in September, Xcode 12 was released. We already got Swift 5.3, currently with Swift 5.6. But the Xcode 12 introduced lots of things, new redesign, always fun. A new icon even, it's now black. And then enhanced code completion, auto indentation. I don't know about you, but I still find that horrible. But I hope they even enhance it even more and more. And if you even look a little bit further to .21, because the year goes quite fast in those 2 years, we have some advanced project configurations where you can specify, okay, I want this framework only in iOS. I want this framework in both iOS and the tvOS. So you didn't have to have separate frameworks made anymore for a specific OS, but you can just share them. That was really great, because in here we had apps for like NLZ and Videoland, where we had both an iOS target and a tvOS target. But if we want to share some code, we had to make a framework for iOS and a framework for tvOS. So that was like duplicate code. But now we could merge that together in one framework and then use it all around, which was great. Unfortunately, iOS 14. Swift concurrency got introduced, of course, for iOS 15 with the Async Await. So that was kind of unfortunate, because then when Xcode finally came around, everybody had their fingers crossed on, please let it be backwards compatible. But upon release, it unfortunately wasn't. We still got Swift 5.5 with a lot of great features, but the concurrency support was only for 15 plus. Luckily, it was still cited as a known issue. So everybody kept their hopes up. Like every time, like, okay, please let it be a known issue to try to get it backwards. But we also got like auto import. I don't know if you ever tried it, but if you call a class that's like from a framework or whatever, Swift will automatically import it for you. Some feature that you think like, why wasn't this in the beginning? But apparently the focus was now. And of course the custom documentation by doc. I've never used it before yet, but it's possible. And finally, in December with the Xcode 13.2 release, we got Swift 5.5.2, very specific. It's only one proposal accepted, and it was the concurrency support for backwards compatible iOS 13, which is great. Because if we look now at March, like 2 days ago, Xcode 13.3 got released, and we finally have Swift 5.6 with 12 proposals implemented. I don't know if you've checked it, but there are some fancy stuff going on there. Having explicit any types for protocols, and also you can declare your type as a _? As saying, Xcode, please figure it out yourself. I don't care about it currently. I'm going to continue developing, and in that way you can ignore your error. You can also just declare it as a _. So you have, for example, let number is _ 5, and then it will figure out that's an integer. It's kind of a fun syntax. I'm going to be wondering if I'm going to use it a lot, but probably during like protocol development and like a lot of generics, it's very useful that if you don't know the type yet, I'm just put it as a _ and then figure it out later. But luckily, Async Await was introduced in iOS 13, and even though it has been 2 years, I don't know about your projects, but our project still supports 2 years backwards. So like the last few months, we decided to drop iOS 12 finally. Our product owner agreed with it. So we could finally start looking at iOS 13 features. So we went all the way back to 2019, before Corona, like the great times. And we just like, okay, what was all released back here? Let's focus again. Like we got really hyped in 2019, but let's re-hype ourselves so now we can actually implement this in our production apps. And well, iOS 13 was introduced. The Swifty table view and collection views, so you have now a diffable data sources, so you don't have to implement the delegates and data source protocols anymore, but it's now a diffable data source Swift generic type. If you want to know more about that, there are lots of videos around. I even made one in 2019, but it's a really great API, it's really powerful, and you can even declare like horizontal and vertical scrolling in just one layout instead of having multiple nested collection views. You don't have to do it anymore, it can be one collection view. Combine got introduced, like a lot of stuff was happening in 19. Swift Package Manager got introduced with Swift UI, and I don't know if everyone know that yet, but also Catalina was, was dropped. But we're currently not still using it. It's a little bit awkward, but well, we will mostly focus on iOS apps. But with that, we're gonna do some coding time. And the goal of tonight is, well, my project has like iOS 12 support. Simplify it into like some workers that have services implemented. So I have like a worker A and a worker B, and my worker C implements both A and B. It wants to combine that data, use it, and then pass it on to the view. And I used to do that with completion blocks, as we all used to do. And I want to rewrite this to async and see where we can also optimize this. It's going to be our goal for tonight. So, oh, that's too soon. I'm going to open Xcode, and I hope everyone can read it. Please say if you can't. But just a small overview. We have our app delegate. Well, it's nothing interesting, so I'm just going to go straight to my view controller. To stay in the current situation, we have a Corona entry pass worker, which is a protocol with an invoke method that expects a person, because we're going to try out like a person, and we're going to check if they can entry our company. With the completion block, with the result, that just is a valid boolean, or either an error that says, oh, it's invalid, it's a PCR error, or an antigen error. And then if we look back in the view controller, we use the dependency injection resolver, because with dependency injection we can control way more what's going on. We can start writing unit tests for it, and we use resolver for it. And you can declare it with injected, so you don't have to worry about constructor initializers or method initializers or even variable injectors. You don't have to worry about that. Resolver takes care of that for everything, and it's also compatible with SwiftUI, so it's a great dependency injection tool. It's also built on Swift 5.5, so it's using all the new features. And we're just going to call it with a empty person, because the person is just an empty struct. For this demo, it's not needed. The information is not needed. And on the success, we're just going to debug the print, and then on error, we're going to handle every error. Like, okay, if it's an antigen error, we're going to handle that. If it's a PCR error, we're going to handle that. Or if it's just an invalid error, we're going to handle that as well. As you can see, already a lot of boilerplate going on. And if we look at our antigen test worker, it's almost the same. We have an invoke with a person, also with the completion block, with a different kind of results, and a different kind of error. So we have if it's positive or not, and for an error, if it's an invalid test, if the person is invalid, if the person is not found, or too many requests start going on, like he put in like 6 sticks in his nose, that's too much. And we have the same for the PCR test, it's almost similar. We're also going to check for the person, and the result is either the person is positive, but he has a valid proof of recovery, and if the person has symptoms or not. And also here, if it's invalid or an invalid person, or if it's person not found, or too many requests going on. And if you look at the implementation of it, you would used to have like some API calls, some more dependencies in here, maybe an SDK framework, some mappers. But for the sake of this example, I just made a dispatch queue to the background. You should never write it like this, of course, but because you can't inject this way. But just after 2 seconds on a background thread, I'm going to return a success with false, true, false. As you can see, with its positive is false, but I have a valid proof of recovery, and I don't have symptoms. So you would say, okay, I'm valid. And for the antigen test, it's the same. I'm just going to return is positive, false, also after 2 seconds on the dispatch queue. And the real logic is going on in our Corona entry pass service, where I have 2 services as a dependency. So we have our PCR test worker and antigen test worker. And as you can see here, we're first going to check, the PCR test worker. We're going to invoke with our person. We're going to switch over the results. If it's success, we're going to start checking our antigen test worker with the same person. We're also going to check the request, and then on the success, we're going to do a lot of logic saying, okay, if it's positive, has valid proof, has symptom, etc., etc., etc. I just made a random guess of what it could be. It's not the official code, of course. And when it's a failure, we return specific to our caller. It's an antigen error, because I would like to know if it's an error all the way back in my view. Okay, which of the services did fail? I don't know. I want to know specifically if service either A or B failed, because then I can debug much quicker. Like I can also just say, yeah, failure, but then it won't help me if something goes wrong. And the same for the PCR, and return the error. And that's why I made a specific case in here that can return this error so I can debug further and further. You would say you can also have network error or even more. And as you probably can see, this is already not really efficient. A lot of code blocks going on, and I'm not doing them in parallel, like I'm doing them one after the other. But I can just do both of them at the same time. It would be more efficient. And to write that the old way was quite a hassle, because you had to get use of a queue, like a dispatcher work queue, and then notify if it was ready. Then you can continue with both requests, or you could even way old school have a boolean and check when it was done, if it was the other request was also done. But then, because both of them are starting on a background thread, you could have database issues happening. So it was quite a hassle to do this before. And you could even introduce Rx to make it a little bit easier, but then you had a lot of boilerplate code. So today we're gonna migrate this to async, and we're just gonna use our PCR test worker. And what you would first do is you keep your current implementation there, so your code doesn't break. But we're gonna just modify this to the same syntax, but instead of having a completion block, we're gonna say async throws, because we just want to throw our error if it's an error. We don't want to pass it along as a result block, because we don't really care, like only in our UI we're gonna handle what kind of error it is. So we're just gonna want the result back here. So we'll specify PCR test result. And with this you can already say to Apple, okay, this is gonna be an async function, and it can be thrown, so we have to do our do catch around this. Then if we go to our implementation details, we can start writing our async function in here. And instead of like what we used to do is a return. Like in here you can already see an issue. I want the same dispatch queue in here, but it uses a completion block. But I want to write my code in async. Luckily, Apple has a way to wrap around like SDKs or old APIs that doesn't support it yet. And then you will say return with checked throwing continuation, or you could use with continuation. The difference is the above one can also allow you to throw code in your completion block, which we want. The other one is, for example, if you just want to return the result, you can still use this one and you just return the completion block as you were used to. But I want to throw my code if it's wrong. So I'm just going to hit enter, and then getting a continuation in here. I'm going to just write it down as this with a lower capital C, of course. And then in here, I'm going to call my dispatch queue. You should see it as if I'm calling an API or an SDK. So if I return this, again, now it's complaining about I cannot find what you want to return, but instead of completion, we'll have to call return continuation, and then resume returning, and then our object. It's going to do it a little bit cleaner, so it's more readable. And as you can see, it's already expecting this type, which is nice because it can identify it from here. So that's the Apple API is really helpful in here. Never return the result. If it's correctly, I'm gonna try, because it's throwing, of course. And I'm not gonna do catch, because I just whenever an error happening, I wanted to go along with it. Yeah, await. Those are always fun things to remember. You always have everything that's asynchronously should always be awaited, and because it's throws, it should always be tried. But with this, we wrapped around our current code to use the default implementation. But we're gonna resume the returning result. You could also wrap this with checked throwing continuation around this method. And how would that look like? That's then like this. So you would, instead of making the same implementation, you would call self.invoke with person and completion, and then switch the result. And in case of success, you would return the same continuation. There's one thing, one downside. You can only call your completion block once. So if, for example, your API worker is returning your result twice, it will crash because you can only return to be allowed one stream. You cannot be allowed to return multiple times. With completion blocks, you're allowed to call it multiple times, but we don't want that. We only want to fire our API once and then handle one result, not both results, if we get multiple. So there's one thing to always making certain that your code does with the completion block only returns once. I even found a bug in an SDK once while trying to wrap it around, because it was calling its completion block twice when an error happened. Like first in one of the steps and then again in another step. So I had to make a Boolean wrapper around it, did already called continuation to allow it to work, because I didn't care about how many often it failed, but I only want to care about it once. So it's a great validation of your API as well. But in here we're just going to resume returning our response. And if it's a failure with our error, we're not going to throw it, we're going to return our continuation because it's expecting something to return, with resuming throwing our error. And with this piece of code, you can still use the old implementation, but everywhere in your code where you want to use async, you can use the new method instead. So you don't have to rewrite your entire code base, but only on the places you want it to be. So I'm going to just leave it like that. So we could eventually remove this, but if I remove it now, I have to rewrite my Corona test worker as well. But I only want to rewrite on one specific place first. Next up is kind of the same, our antigen. So I'm just going to use my copy-paste skills to make it a little bit quicker. But in here as well, we're going to just call the same method, invoke, but without the completion. We're going to just throw our error if we got across one, and we're expecting a result back, which is great, so we don't have to switch again. So because of our great copy-paste skills, we're going to go ahead to our antigen service. Luckily, it's almost the same. Well, it's exactly the same type of call, but I only have to return another antigen test result, else we're not conforming to our protocol. But in here as well, as you can see, we're just going to call our default implementation with the completion block. So whenever we use this worker, we can decide, okay, we're going to use the old way or the async way. We're just going to validate if our unit tests are still working. Yeah, we wrote that too, so to check if everything is working. Build failed? No. What's going on? Oh yeah, my mock doesn't work anymore. I'm just going to throw an error here because I don't want to implement this now. So this is also a good reminder, always update your test as soon as possible. Yeah, we can just throw this error, but I want the PCR test error. It's a great way to still validate that everything's working if you made some changes. Build successful. It's testing, running. Well, while it's starting up, we're going to just already look at our Corona test entry pass worker. Well, as you can see here, it's basically almost the same implementation as well, luckily for us, but of course in a real project it will be quite different. But so we're going to abuse this and modify it a little bit. In here, as you can see, I'm still only going to do async throws. I'm not going to bother about specifying that this is this kind of error. Oh yes, our test still succeeds, which is nice. But because our PCR error and antigen error are already happening in our other workers and it's throwing, I don't have to specify that anymore. I can just leave it as what this worker, what this implementation can throw. I don't want to care about its implementation details, because if I specify, hey, there can be PCR error, antigen error, I'm already exposing what services it has implemented. There's a little bit of a code smell, so I want to remove that. Then, of course, I have to rewrite this huge as code, but this was my goal, to rewrite this piece of code. So I don't want to, as I did with the PCR test worker and antigen test worker, to make a wrapper. I just want to completely rewrite this. So I'm just going to remove the old implementation. I'm going to make this commented out so it doesn't bother me while developing. And on top of here I'm going to call invoke. It's already autocompletes because I have to comply to the worker. But now the interesting part happens. Because the PCR test worker also returns my async code, I can write, for example, like this. That PCR test result is try await PCR test worker dot invoke with person. And another one with antigen test worker test result is try await antigen test worker dot invoke with person. And in here I can use this piece of code that I already had. Copy paste it. Fun. Uncomment that piece of code. Do like a Control I to re-indent everything. And instead of returning completion success, I'm just gonna remove every part of it to just only the object. Probably some keyboards in here that's a lot quicker. But in this case, we have a failure. But instead of returning your completion block, I don't have that anymore. I'm just gonna say return throw corona entry pass error dot invalid. And in here also removed, a little bit clean up. Super fun spacing. And if it's correct, it can blah blah. Oh yeah, only throwing is enough. I don't have to return it. It's already go out. So now I've rewritten my code. So as you can see, it's no more indents going on in here, like with the switch and another switch and another switch. But just I want to await my results, get it. Then I'm gonna continue the antigen results, get it, and then I can already use these results on this line. So it will wait before executing the next line. Though, as you might imagine, as I said before, this is also not really optimal, because now it's doing one part, waiting, doing another part, waiting. But they don't have any dependencies with each other. I want them combined, but I don't want to execute them one at a time. And for this, Apple also introduced a new method called async let. So I'm going to call async let. Can remove the try await. Basically, you're saying, please store my asynchronous function in this variable. And because it's still a task, I'm going to say a task, because it doesn't include the result yet. And if you want to see what it looks like, because that's really confusing, it already said, hey, you have the results here. But if I try to call this, like for example, if I want to read out what this is, Apple will already say, hey, you cannot access this, you have to click await first. But you can imagine, I don't want to write await, 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 await. So you usually would wrap it around in a variable saying let PCR test results and antigen test results. You can just wrap it in a tuple to make it easier to access. You can also write it in an array if the responses are exactly the same, but in here both my results are different types. And the only magic keyword is try await my task and the antigen test task, also as a tuple with the same the flow. And with that it means please get these results at the same time. So execute them in parallel, and it will go to the next line once both of them are returned. And if one of them throws an error, it will already stop and go all the way back to where it was called. But only if both succeed, we're going to continue down the line. So this is a great way to execute some code together. For example, if you have like 10 images downloading, you can mark them as an array instead. So you can say try await array your tasks and let results is array. So if I continue to build this, it will probably fail because my invocation of the view controller is expecting a completion block. Yes, it is. So we're going to update this code as well. So we're going to say Corona entry pass worker, invoke with person, it's going to initialize it. And I want to pass down this result, so let response is, and then I'm going to debug print it like it's down here. So I'm going to comment this out. But as we all know, we have to mark it try await, because you know it's a asynchronous throwing function. But now, of course, Apple will still complain, or Xcode, like, hey, you're calling async, but your function is not async. So what you're going to do? Well, to fix that, we need to mark our function also as async, but we're currently not throwing it because in this specific case, well, not you should never do it in your view controller, but for the example, I'm doing it in my view controller. I'm going to handle the result. So I need to wrap my catch in a do catch. So do catch, and you have like let error. I'm gonna re-indent it so it's easier to read. And in here, now the function will not complain, but I'm gonna debug the error. Now our first method is gonna complain, and this will keep doing it, doing it, and doing it. Like you have to decide, okay, on what point am I going to start my async call, and when am I gonna stop asking for it? And here, like I'm at the highest level possible in my view controller. Like on a moment a user clicks on a button, I usually go to my interactor class that handles the business logic, and from there I'm gonna start my service. So you would usually do is wrap it around a task to say to Apple, okay, from this point on we're gonna start asynchronous. And of course, because it's async, we have to call await again. So luckily Xcode is helping out a lot. But in here we're going to start a task, we're going to await the results, and then we're going to dispose of the task. And yeah, this can be removed. Now in our let error, what if we want to have like a specific anti-gain error, a specific error handling? Like we don't want to know everything, but for example, I can specify it as a anti-gain test error dot invalid test or invalid person. I'm gonna handle my specific cases, and if it's neither of those, it will continue on the line. So I can already specify my PCR test as well, or even my Corona pass entry worker as well. Like every single test case I can handle as a separate catch if I want to in my specific use case, or I can handle everything as a default one. I can also cast it as the specific enum and then try and switch over that. But this way you can have a very specific error handling only on the place where it matters. One fun fact, tasks, we learned that today with some research, thanks to Michelle. It will retain everything that's in it in UIKit. Swift UI it won't, but in UIKit it will retain everything that's in it, wait for it to complete your whole method, and then it will de-init. So if, for example, you have a network call going on and your user dismisses the view, and for example it's a get, well, yeah, I want to cancel that, of course, because it's useless to just continue. But if you implement it like this, it will stay alive until the task is complete. So until your mapping is done, until everything is merged back to this view. So that's kind of hard. But a way to capture that is to basically save your task, because if you look at the task, it's nothing other than a task operation. So you can have like a I'm gonna hope if it's still working. And of course, because we're yeah, okay, blah blah. What was the protocol called again? NS.
Practice and avoid never.
Thank you. That's why we have developers all around us. We're gonna store our task. So whenever our view the units typing is fun. We're gonna cancel it, but this will still not cancel our task because it's still retaining self. So we also have to specify weak self in and call self dot. But another fun thing is it's still retaining currently because everything in task is retained even though it's weak. So now our view control is retained until it's done. So you would usually do is have this in another class, like your interactor, for example, or like another class doing your business logic. Have it marked the same with the task and then cancel. But when your view controller deinitializes, because it's not part of the task, that will not retain, you will send a request to your interactor like, hey, I'm gonna be gone. And then your interactor can cancel everything that's still running. Because the view controller will now retain, but if I move it to another class, then the view controller will deinitialize what we want because it's like the navigation. But then our interactor, like our business logic class, will still retain. So we're gonna say cancel me, and then it can cancel all your tasks. So this is something you have to keep in mind when using tasks in UIKit. It will retain everything. On Swift UI, you don't have that issue. And sometimes you do want it to be retained. For example, if you do a post for like a heartbeat or to save progress or to save like I'm gonna favorite this item, you do want to continue that. Or when you store something in your user defaults or your keychain, you don't want to interrupt that. So some tasks you do want to continue, but some tasks you don't. And of course, our unit test will break because we cannot build it because it's using async code. So, but to show, I'm not going to update all the tests because that's going to be a lot of work to do. But to show you the power of like what writing async tests can also update for your test cases. In here, I'm having a mock with the stop result. Of course, I'm going to update my mock to allow my new syntax. So I'm going to say stopped result. Again, is stopped response is a optional PCR test, and for example a stopped error because I want to validate both use cases could be. And then if we have a stopped response, we're just going to return that, and else we're just going to throw our PCR test error, stopped error, or if that's not there, I'm just gonna say invalid, whatever. So it's always returning something because it's expecting something to return. Then in our test case of PCR, like we have our the subject under testing. That's what the abbreviation means. I'm going to register my mock services, of course. In the setup, I'm going to initialize it, and teardown, I'm going to nullify it, so I'm always clean with every test. So I'm not having any objects flying around. So every test has its own case. We used to write for every little test an expectation, which was horrible to do, because even writing this demo, I forgot to call expectation but fulfill. So I was already trying my head around, why is my test not working? Why is it not working? Oh wait, I forgot to call fulfill. I put the timer to 2.1 because of course I have a delay of 2 seconds. And I'm checking if I'm not on the main thread, because I'm on the background thread calling this. That's the only test case I could figure out. But now, given, well, we don't have any parameters going on, so that can be removed. That doesn't have any dependencies, which you might want to set your mock results in here. Instead of checking the results, I'm going to say let my result is zat.invoke with a empty person. Of course, I'm going to call try await again, and then I'm going to just do my last test to see if I'm not on the main thread. And as you can see, I'm not specifying my timeout anymore. There could be use cases that you want to do that. So in that case, you would wrap your try await in another task with your expectation declared above. So for example, let expectation then you would write this in a separate task because it has to be like in completion block going on. And then in here you can say expectation.fulfill, and then you can still call wait for to test if your code is returning after 2.1 seconds. But in this use case we don't want that. So I'm gonna remove the task. It's much better if I just use it like this. I'm not even checking the results, so I can remove that. And I don't want any expectation, so it's given when, then I'm going to check the thread. But because I'm marking this async again, I have to call async. And because I'm trying, I also have to call it throws. In this specific use case, I don't care what error is happening. So if an error is happening, I'm testing my success here. So if an error is happening, my test should fail. So I'm marking my test as a throws. If I want to test specifically on the error, I'm going to remove the throw and do it a do catch and then exert my error here in here. So there are two ways to do that, but usually in your success test you just want to try this out. For the sake of it, I'm gonna disable this test because else I cannot compile to see if this one working. So I'm gonna run this. It's probably gonna fail about our step response. Interesting. Oh, throw, yeah, thanks. Let's hope this still works. Yay, your test still succeeds. So you can see here, well, we can also validate that. On first, we're on the main thread. So that's always very hard to to keep in mind that whenever you call await, you can return in another thread from that point on. So usually with the completion block, it was more obvious that it could return in another thread. Okay, I'm not on the main thread. Cool. That was interesting. But usually, let's trying out. Usually with the completion block, you might suspect, okay, this can be a main thread return or not. You're not entirely sure. But then at least it was obvious. Now, well, yeah, it can just change threads whenever I'm going on. I'm curious if, because this is also trying out, if it's the same thread. Thread is thread but current. What happens now? I'm not sure how Apple does the unit testing, but I would expect it to not be equal. Because I'm dispatching on a global queue, yeah. As you can see here, that we started on a specific thread, and because of our invoke method, so if we go to this implementation, we're going to a random global background queue, and then returning on it, so not on the current thread, but on the new thread. I was expecting that it's not the same, so luckily it is not. So with this, I would have to remind you, keep in mind that with every line you can change threads. So you have to keep in mind for that. So with every await, you can change threads.
What happens to your stack?
Will be quite fun to see in your stack. Yeah, you have multiple threads because the other thread is still waiting for the other thread, and then yeah.
So you can have your deadlocks and stuff.
Yeah. So you have to keep in mind not to start threading too much, and like your task is always executing on the background thread already. So if I go to my view controller, this part, this line is already on another thread. It's not anymore on the main thread. And because my return response is also on another thread, that's also that's already two threads going on at the same time. So keep in mind with concurrency, a lot of headache is coming your way. And keep in mind that you don't switch around too many threads because you already are on a background thread. And your API will also be on another thread. And hopefully it would return on your same thread that you invoked it, but you can of course specify that. But in default it will go to your main thread. And that was it. Thanks all for listening. Any questions? You can get the boombox.
Yeah. You said, is it working? Oh, I don't know. Okay. So you said you had the task and it's retaining in your view controller. But when you cancel it in your interactor, how does it know to the init then?
You would your view controller would have a reference to your interactor, where in your interactor you have your task starting on, your dependency injections, all your business logic, and then you will call your presenter to display to your UI. But your view controller is not part of the task. So your view controller will get deallocated whenever your user dismisses your view. And then on the deallocate callback from your view controller, you'll say to your interactor, hey, please stop the task. So you give like a sign to your interactor, please stop. And then in your interactor, you have like a function declared that you will cancel all your tasks that you've saved or stored. You're gonna call cancel.
All right, clear. Thank you.
Oh, and keep in mind, your jobs, like task, is a very fancy. It will look at cancelable protocol. So everything that's within that task that has the cancel protocol will get the cancel initialized as well. So your URL session will get that same cancel, and it will try to cancel your request as well. So if you have like a custom mapper, you can implement that protocol to decide what you're gonna do if a cancel comes in. Because task will automatically do that for you, which is very nice. Nice try.
I was wondering, when you create a function and you say async throws, don't you have to declare what kind of error it throws, or is it optional?
Now currently it's always a Swift error that it throws. You can also specify what kind of error it throws to help you out, but if you want to pass it along, then it won't know anymore.
It's easier to just assume it's an error.
Whatever you're throwing must conform to the error protocol from Swift.
That's it.
Yeah.
Okay.
But in that way, as you can see, I don't have to specify my enum with a nested, all the errors in there. With this, we could clean up a lot of code and just only handle it all the way back where it matters, in our interactor. When something fails, I'm going to say, oh, was the network error? I'm going to retry. Was it a mapping error? Oh, I'm going to display this to the user. So it's
Cool.
much. I really liked it implementing that way.
True.
Another yes. My question is about that you talked changing threads and maybe it's missing, but how you basically moving back to main? Do you use just main actor for the function or something else?
Yeah,
or
it depends on your use case. Like if you have like, for example, if you mark your vControl as a main actor, that would be quite easy to do. Then it makes sure that everything is on the main thread, but it also comes across a efficiency, because if everything is wrapped in a main actor, it will cost more time for Apple to switch threads. So it's rather quite faster to just use a dispatch queue, that main async. You can write a little wrapper around it, but that's a little bit faster. But if you want to make sure everything in a specific view or specific file always must be main thread, everything, then it's better to use main actor, because you don't have to worry about everything thread saving. But for example, my interactor, if I would use this task for every request, and if I have variables in it, I'm gonna have a database issue, because I'm not sure on which thread it will return. To solve that is to either make my interactor an actor as well, or write my own dispatch queue and make it async with sync and flag barriers to make it thread safe. But in there you're gonna have a lot of concurrency fun with data races, and if you ever see an bad access crash, it's usually a data race issue. But you can also turn it on in the scheme settings, and it will notify you, hey, I think a data race is going on here, and then you can really quickly identify where it's going on.
And another question, did you try to use actors?
Yeah, currently we're not using actors yet, because our code base is still iOS 12, so we're starting slowly like this, implementing asynchronous functions everywhere. But because currently in our logic, we're going from an interact, like a user clicks a view, It will call the interactor, it will call some service, that's async. It will then go to the presenter, it will make some view models, and then we'll go to the UI, and only on the UI we're always, as default, dispatching to the main thread. So we're not currently using actors, but just dispatch. But I think it's a very interesting use case to start using actors once our code base is ready to do so.
And out of curiosity, would you have a tip for any beginning developers on how to start mastering this new tool?
Yeah, just look at your least dependency services, like some piece of code that doesn't have a lot of dependencies. Start writing from there, and as you can see what I've did, start wrapping around it. So you can use both ways. The old way, so you don't have to modify your whole project, but only where you want to work it on. So just start small, and then start using it, start exploring it, and always keep your memory debugger next to it to see if you retained something, because that's a really great addition to start with.
Is it easier?
The cube.
If you compare this with Combine, because you started the project a year ago, and instead of result, we use Combine flows everywhere, even though you only get one result back, combined to the max. But you said also like, hey, sometimes you get callbacks where you get a callback twice. With Combine, it's of course easy to combine. That's the name. Would you not rather use Combine for that instead of Async Await? If you, for example, to combine two API calls into one result, like you do here, you can also do it with Combine.
Yeah, good question. Personally, for APIs, I would still rather use Async Await, but also because currently our logic is not like RX based, like functional based, with like a lot of streams going on. With everything that's only like fire and one result, I would prefer to use Async Await. But if I need to observe something or like a stream of data is coming, I would definitely go switch to Combine, because that's the power where you can use that feature. So then I would rather switch to Combine and use that functionality. Like, I think there's not like a you have to use everywhere try await or everywhere combine. I think it's very specific use cases, and with streams of data and observing, I would really recommend use Combine. But just for fire and forget, I would write async, because you can just remove all your completion blocks. It makes your code a little bit easier to read. It would be fun to see how it works together, like try await combine.